accept. Okay, so these are those review videos that we can go through, and if you want more practice, this practice 1 we did not do yet, so you can go through that. When you click on it, let me do that really quick. Click on it, and I'm going to hit pause. Down here is the actual link right there, is the link to the practice question. So you can click on there and get to the, there's a checklist that we need to go over. Oh, they have the periodic table and the equation sheet on here too. Here is the Wednesday sample that I gave you, and this is the FRQ 1 and 2 from the Mondays. So we didn't do this or this one, so you guys can go there. Okay, and this is the document that I wanted to go over with you guys. It's just little helpful things of what you should say and what you should not say. And I'm not going to go through everything. We'll just highlight the ones that I think are really important. Who popped on? Hi, Eli. I'm recording, so you can have your smiling face, or you can just put the E if you want. Okay, so this is what you should write in the left and what you should probably not write in the middle, and then the rationale tells you why you should do that. Okay, so instead of saying it or stuff, we should say species, or you could be more specific and say reactants or products like it says up here. So species is just if you're not sure. It's something instead of it or stuff. Okay. Oh, I actually like this one and I skipped over it. Answer the specific question first and then justify or explain, because it gives you, make it easy to give you points right there. It either increases, decreases, or stays the same, or you agree or you disagree, or you're choosing diagram 1 or you're choosing diagram 2. So if you state the answer first, then it makes them very easy to grade and give you guys the points there. Okay. Refer to the mass and the volume instead of the size. Another one would be the radius. You could talk about the atomic radius instead of just saying it's big or small. Say the atomic radius is larger. Okay. Net ion equations we went over since we got out. So if you didn't look at those ed puzzles that I gave you guys for net ionic equations, make sure you do those because we didn't do very many. And when we did do them, I think it was in September. So review net ionic equations from the ed puzzles I shared with you guys. If you put an aqueous ionic compound in its undissociated form, like NaClAq, you're going to have spectator ions in there. Okay, so one of them is going to not be involved, and then it won't be a net ionic. It'll be a molecular or a complete ionic equation. So if they specifically ask for net ionic, make sure you separate the soluble ions. Okay. You guys are pretty good at these diagrams. Okay, whoops. Make sure you have units in your answer. The only time that you don't need units is if the question says how much energy in kilojoules. Then if you put 45, they're assuming that it meant kilojoules. But if you put 4,500 because you were in joules and it asks you for kilojoules, you won't get that point. So make sure that you put the units that you're working with. If you had put 4,500 joules and it was 4.5 kilojoules, then you could still potentially get that point. Okay, so make sure you include the units. You have to show your work for these. If you just put an answer with no work, then they will not give you the point. Okay, so make sure you show some work. It doesn't have to be every step because we are going to be rushed because we have a little bit of time, but make sure you put some kind of supporting work to show how you got your answer. Okay, and you do want to use sig figs, but usually it's only like in the example where you had to read the burette and you had to put the like 18.18 you had to put that hundredths place to get that point. That's the only time they usually count off for sig figs. So, but it's still better to be safe than sorry. So watch those sig figs. Okay, I'm going to skip over gases. You guys are good on gases. For thermodynamics, remember delta H, the enthalpy. If it's exothermic, you need to memorize, or you don't have to memorize because you can have your cheat sheet next to you. For exothermic, delta H is negative. For endothermic, delta H is positive. And I would even have a little diagram of an endothermic and an exothermic reaction there. Okay. For kinetics, if they tell you to find K, remember you write out the rate law. R equals K times the concentration of the reactants, and you have to figure out the exponents. If it says find K, you just plug in the data into that rate law. And so if it's cubed or squared or whatever it is, leave the units there and keep them. And I can go through an example of that if you guys wanted me to, but make sure you have those units of K there, okay? Because it says right here, the units, if it asks for K with units, it's required to earn the point, okay? For kinetic specific parts of the molecules have to collide, we know that. We know orientation is important, right? Collisions must occur in the correct orientation, but if we just said that, we need to be more specific. What's the correct orientation is what they are looking for. So example, if you had NO and NO, let me draw it this way or make it this way, and they have to collide in a specific way for, let's say, the two oxygens to come together and bond, then you want to say NO needs to collide with another NO so that the oxygens are aligned. Instead of just saying they must have correct orientation and moving on with your life, you have to be more specific. Okay, saying what is the correct orientation. So then you have to kind of look, and they'll usually give you the little molecules to look at so you can see, okay, well, that one has to hit that one in order for them to form the product where they're stuck together. Okay. Rate law includes the rate constant K as part of it. We need to put K. You guys will remember that. So I would have, you have your thermodynamic little cheat sheet next to you where you have endo and exothermic and the energy diagrams. For kinetics, I would have the equation, A plus B makes C plus D, and then write out the rate law. So R equals K, A to some exponent M, and then B to some exponent N. So make sure you have that and make sure you include the K there. We would never write a rate law without the K. Okay, it's only based on the reactants because the products don't affect how fast the reaction happens. Okay, and then we practiced one of these, this Q versus K business. Remember, Q is just like finding K, but it is when it's not at equilibrium, and then we can compare the two. So instead of just saying we're trying to reduce the stress, I have trouble with this one. I think you should say due to Le Chatelier's principle. It could shift right or shift left or proceed right or proceed left based on if Q is bigger than K or less than K or even equal to, if it's equal to K, then it's not going to proceed either direction. Okay, and this part right here, it proceeds, it only shifts right and shifts left if it's at equilibrium. So this is just a warning. If it's talking about Q going left or right, I don't think you would lose the point. If equilibrium is not yet established, then it cannot shift. The reaction will proceed in a certain direction. I don't think you would lose the point here. So if you said shifts left and shifts right, that's kind of what we practiced, you'd be okay. But you could say proceeds left or proceeds right instead to be safe. KSB expressions only contain the ions. So remember, a couple of us put a solid in the denominator. So there's nothing in the denominator when we're talking about KSP, the solubility product, because you're starting with a solid, and that pure solid is not part of the K. Okay? Solids and liquids aren't in there. Correct formulas, including charges for all species, substitutions, chargeless ions, shorthand. Equilibrium expressions must be written formally when requested. So make sure you put the charges. If you're doing a KSP, you want to put like NaCl, Na plus, Cl minus. Okay. X has been assumed to be so small relative to the original concentration, it can be ignored. Nothing about why you ignore the X. Oh, okay, so if we are, remember it's almost always an X is small assumption, but make sure you put that X is assumed to be so small it's negligible or it can be ignored. Okay, shows you understand why you are making the decision. All right, oh, I skipped one. In KP expressions, P, use the capital P, and then the species down here is whatever you're talking about. So if it's into, you put P into as a subscript, or you could even put it that sub line if you're typing, or sub into if you're typing it. Okay, just if it's K up here, you're talking about concentration. KP, it's going to be a capital P with that, or remember, no, not or, and up here, K, where its concentration is in brackets, and down here, P, where it's KP, is going to be in parentheses. So that's easy to remember. P for pressure, parentheses. Okay, and K, it's usually just K or with a little C for concentration. It's going to be in brackets. Concentration is not used in KP, but partial pressures are. Okay. All right. I'm going to mostly skip over acids and bases. There is a tiny bit of them on there. So if you look at the units, which maybe we can go over that in a second. There's a little bit about acids and bases, but there will not be titration curves. There will not be buffers on the AP test this year. Okay. Where we left off, that's not going to be on there. Okay. Atomic structure, effective nuclear charge increases. That would be like, why is fluorine the most electronegative? Because it has the greatest effective nuclear charge for its period going across. Okay, and do not say it wants to have a full octet because it doesn't. All it cares about is, remember this whole entire section, I should just put in parentheses next to atomic structure, Coulomb's law. Okay, it doesn't want to have a full octet. Why does it get a full octet? Because of its high electronegativity, because of its greater effective nuclear charge, right? And its smaller radius, greater charge, greater radius means it has more pull on the electrons. Okay, and do not say it's full to having a full octet. That won't get you any points. Okay, the actual reason and not the memory aid. So having a full octet is just kind of like the outcome. It's not the why. Okay, it has more pull. This one is really important. We didn't practice this enough. For all the intermolecular forces stuff and atomic structure, if it says this one has a higher boiling point than this one does, justify your answer. Or this one is more easily melted, is more easily melted than this one. It comes down to a more polarizable cloud of electrons. These are the magic words to get you the point. Okay, if you say it has more electrons or it has more mass, it has more surface area, it's bigger, you're not certain to get the points there. Okay, or it has more protons even. If it's talking about intermolecular forces, they are due to the cloud of electrons being more polarizable. Okay, this is the shortest way to show the reason. Simply mentioning more of something is probably not enough to demonstrate without further explanation of why that is the case. So it is more polarizable, or the electron cloud is more polarizable. Okay. Mention the period that it's in and not the shell when you're talking about the periodic table. That's because elements are in the periods going down. Remember, there's 7 periods. You can even have your periodic table printed next to you, which you should have, and then put period 1, period 2, period 3, down to 7. Okay, remember these are groups and these are the periods. Reference reasons for periodic trends, as in Coulomb's law, right there, Coulomb's law, which is the effective charge and the radius, the distance between those outer electrons and the nucleus, and then polarizability. Okay, so these are our magic words, Coulomb's law or Coulombic attraction and polarizability. Okay. Okay, so if you said something like, because nitrogen is left of fluorine, it's less electronegative, that will not cover it. If you said that the coulombic force on the electrons in nitrogen is less than that of fluorine because of its lower effective nuclear charge and its greater radius, that would be more correct. Electrons in higher energy levels are farther from the nucleus, resulting in a larger atom. Electrons are in a higher energy level. The energy level, remember, is defined as the distance from the nucleus. If you said more electrons, more energy levels make the atom bigger. That is very similar. Explanation of the reason, not just statement, required for the point. Reference 2016, number 1. So don't just say it has more electrons, therefore it's bigger. You would say it has electrons in higher energy levels, making it a bigger atom or a bigger ion. Okay. Overcome intermolecular forces. So if we said, why does sodium chloride dissolve? We could say that the water overcomes the intermolecular forces between, that's a bad example. Why does water melt? Because it has enough energy to overcome the intermolecular forces. Better example. Instead of the solid breaks up. Why does it break? Because it has enough energy to overcome the intermolecular forces between them. Okay. Ion interactions, I don't think we would do this, but London dispersion forces do not apply to ionic compounds. We said everything, but that was confusing. By everything, I meant polar and nonpolar, which is talking about covalent things. So that's a good one that we review. If it is the ion dipole force between Na plus and water, H2O, there's not going to be London dispersion forces there. There's just going to be the ion dipole force. Okay, it's not dipole-dipole either, or hydrogen bonding, because it's an ion, not a dipole. Okay, fully ionic. So ion dipole is different. Coulombic attraction is what we want. We would never say opposites attract. Okay, describing the process of overcoming intermolecular forces and polarity. If we just said like dissolves like, I slightly disagree. You can say like dissolves like, but then you have to say why. Why does polar dissolve in polar? Because the attraction of those opposite poles overcomes the intermolecular force. But you can start by saying like dissolves like. State the actual reason, not the memory aid. Okay. It has hydrogen bonds between the molecules. Where are the hydrogen bonds? If it's talking about hydrogen bonding, remember hydrogen bonds are really tricky. It's not in water. It's not the bond between the H and the O in a molecule. It's two waters and the attraction between the hydrogen on one and the oxygen on the other one. So it's between the molecules. It's not this water molecule has hydrogen bonds. It has hydrogen bonding between the water molecule next to it. Okay. Ionic compound is what we would say. What do we not say? Molecule. If it's ionic, it's not a molecule. Call them ions if it has a charge, not atoms, and vice versa. Lewis structures are complete with necessary lone pairs. Okay. If you need to go back and review Lewis structures, because that's been quite a while since we did those, go back and find some examples of Lewis structures. Identify specific intermolecular forces, stronger. I think, again, this is one where I would start here by saying it has stronger or weaker intermolecular forces, and then say why. If it has stronger intermolecular forces, it's probably because it has more polarizable electron clouds. Shh. Dissolve when discussing interactions between molecular substances. And so if it's molecular substances, if it would be isopropyl alcohol in water, the isopropyl alcohol will dissolve in the water. It doesn't ionize or dissociate because the isopropyl alcohol is not, they're not bonded together. Okay, so dissolve just means that it's going to mix with the other molecular substance. Well, okay, that's kind of confusing because most things that we're talking about, like salt, any kind of ionic thing is going to ionize or dissociate. I guess this is just when it's molecular, just when it's covalent. Okay, we don't say ionize, we would say dissolves. Okay, and electrochemistry we get to skip. So we don't need to even worry about that. I think the last unit that I'm going to give you guys, which would be optional just for your grade, is electrochemistry. Okay, and what I wanted to share with you guys, let me pull it up real quick in my Google Docs. Any questions you guys have, you can type them in the chat if you want, or you can unmute. Where is it? There we go, AP Chemistry checklist. Okay, so just a heads up, this is something I'm going to share with you guys tomorrow, so you'll know what to do. You're going to go File, you're going to make a copy, you're going to put your name right here, so I know it's your checklist, so you could put Mrs. V, AP Chemistry checklist, cancel. And then I want you to go through and check off all of these things and print this out. So you need to print your equation sheet right here. I linked to the equation sheet. Okay, having this printed out, I mean, if you absolutely can't, I would bring it to you if you need it, really. But if you absolutely can't, and you just need to have it pulled up on a separate device so you can refer to these equation sheet, to these equations, okay? And then the periodic table, same thing. Get that printed. If you can't, let me know and I'll get you one, okay? Or if nothing else, have it pulled up on a separate device. Put your AP ID, like do this as soon as I share this with you guys tomorrow. Make sure you have your AP ID because you're gonna need that to type on the top of your document or to write on the top of your paper. Like remember we did this right here. We did the pretend one. 1, 2, 3, 4, 5, 6, 7, 8. You need your real one. Okay, so type that there. And then this tells you what time you need to check in, what time the exam starts, and then go through, am I ready to test? Go through each little section here. Okay, you have 2 documents prepared, one for question 1, one for question 2, or you have 2 pieces of paper ready to go with your AP ID, your initials, and the page number at the top for question 1 and question 2. Specific materials, that's your periodic table and your equation sheet. Reviewed the exam security guidelines, check. If I've been approved for accommodations, you'll have a little extra time. Okay. During the exam, make sure you read over these things. Don't hit the back browser and don't close the tab. Okay. If that does happen and for some reason you get kicked out, you can go back into your email and click on your ticket, your e-ticket, and you can get back in and start from there. Okay, it should pick up where you left off. Okay, let me go back and see if you guys had questions. How many sig figs need to be in the answer? And Q. I will definitely share the what you should say. And I'll go over those 2 things right now. Okay, I'm going to email this to you guys. This is from Kimmy Bear. Okay, make sure I don't share my email. You guys don't need to read it. Okay, it's thinking about it. AP Chem 2019, 2020. What you should say sheet. I emailed you guys the what you should say sheet. And how do you find Q? So Q is just like K. Let me give you an example. Note, new lines, share this instead. Okay, so let's say we have N2 gas plus O2 forms or is in equilibrium with 2NO. Okay, and the question is write the equilibrium constant expression. So you have your capital K. These are all gases, so I'm going to put a little P here. Okay, it would tell you all of that, and it would say find Kp for this reaction. And remember, any constant is just going to be the products. So we have NO, NO, and the coefficient becomes the exponent, so it's squared. Okay, over the reactant, so we have N2. That's an ugly 2. And O2. Okay, so this is our K, I almost said Q. This is our K. Now, the second part might say, for this system, you added a certain amount of oxygen, and here's your new concentrations. Which way is it going to shift? Well, if it's going to shift, that means it's not at equilibrium. Or which way will it proceed? So you would say Q equals the exact same setup, but now these concentrations are not the equilibrium concentration. So they'll give you numbers. So let's say it was like 0.8 atmospheres, 0.8 ATM. These are just givens from whatever the question was, squared. Okay, oh my gosh, I just did what I told you guys not to do. Abort, abort, pretend I didn't do that. Okay. Get rid of those. What should I put instead? I was testing you all. I'm going to look at the comments. If you didn't yell at me, you failed that test. Parentheses, right? Because it's P, not C for concentration. Okay, all right, we caught it. We still get our point. So plug in the concentrations, and then let's say this was 1.0 ATM. ATM. And this was 0.5. Okay, so we are just going to do this calculation and find an answer over here. Yeah, I don't want to do this math in my head right now. We could do it, but I don't want to. Dividing by 0.5 would double it. We got to square that and then double it. So we have a certain answer. And notice that the units would cancel. We have atmosphere squared over atmosphere, atmosphere. So there are no units for Q or K, and that's okay. That's not like the rate law. For K, there's none. For capital K, equilibrium constant, no units. Okay, so that is how you would find Q. I hope that answered it. And then sig figs, remember that there's really just 3 rules. Rule number 1, if it's a non-zero, it's significant. So all non-zeros, automatically significant. Okay, rule number 2 is if it is it only counts if it's a 0. Trailing 0. Trailing. What does trailing mean? Trailing means on the right side of a number. We haven't gone over these in a long time either. Trailing 0 after a decimal. Only when it's after that decimal does it count. Okay. After a decimal. And then 3, the sandwich rule. 0. Sandwiched. Those are significant. Trying to write on here is funny. Sandwiched between two significant figures. So this would be like 1001 is going to have 4 sig figs because these zeros are sandwiched between the two non-zeros. This one would be like 0.00020 has how many sig figs? Well, these are not trailing, so these don't count. This one is trailing, and it's after, to the right, of a decimal, so it has 2 sig figs. Okay, and then any number 1 through 9 is going to be significant. For multiplying and dividing, so if you're doing a K problem where you're multiplying and dividing those numbers, you're going to use the one with the least sig figs. So if they give you, let's go back up, they give you these numbers, well, this one has the fewest sig figs. There should be 0 there. This one only has 1 sig fig, so your answer can only have 1 sig fig. Okay, but if you're adding or subtracting, and here's the one that they always try to get you on, they give you that burette reading, or it could be a thermometer reading, and they usually like to do the burette because you have to know to read from the bottom of the meniscus. So if they give you this, you have to record it to, if it's in milliliters, the hundreds place. So you want to record those 2 decimal places. And then if you're adding and subtracting, the rule for sig figs is different for adding and subtracting. So if this was, let's say, 0.12, and you're adding 1. Whoops. No, I'm just going to leave it. 1.15. You're going to add these up. And even though this one had 2 sig figs only, your answer is going to have 3 because you go by how many decimal places the one with the fewest had. So this has 2 decimal places, and that means that you're going to have 2 decimal places. So it'll be 1.27. Let's say it's milliliters. Okay, so your answer actually has 3 when this one only had 2 because you're keeping how many decimal places it had. Okay, so those are the sig fig rules. I hope that answered that question. Relationship between K and Q. So, making sure I covered all of these. Okay, the relationship between K and Q. Let me go back. I can do that real quick. Going back up here, let's pretend that we had the value of K was given 64 times 2. I'm just going to say this is 1.2. I know it's not, but let's just pretend that it is. Okay, no units, that is what Q is. Up here, let's say that K was equal to, let's make it equal to 1. What does a K, a constant value, equal to 1 mean? That means that neither side is favored. So these are going to be present in equal amounts. You're going to have as much of the product as you have of the reactants. Okay, that rarely never happens, but it could happen. So if K was 1, then these two things will come to a balance point where they are equal. Down here, if Q, if what I set up is 1.2, now the relationship between these two is I'm comparing this to this, and I can see that Q is going to be greater than K. Okay, and that tells me something. There's a lot of little tricks that you can use to memorize which way it's going to proceed, but it's better if you just use logic to work it through. So if this is too big, then that means the top is too big and the bottom is too small. So it's going to proceed in a way where this goes down and this goes up. What does that mean? That means this NO2 has to decrease and the N2 and the O2 have to increase. So you would say it proceeds to the, now you would write this out, but I'm going to be really lazy here, proceeds left. Okay, that's what this is telling you. If you found that Q was too small now, so let's say that this Q is 0.8, That means to get to equilibrium where it's equal to 1 and it's starting at 0.8, I need more product and less reactant. So if it was the opposite of this, it's going to proceed to the right. To decrease my reactants, it's going to have to react and shift to the right. So this one would be the one that's going to happen more, okay, until it reaches that balance point again. Okay. And how many sig figs should be in the answer? I hope that I wanted to review the easy sig fig stuff for everybody. I know not all of you needed that, but wanted to go over those. And then remember, it's different if you're adding and subtracting. It's decimal places. If you're multiplying and dividing, you look at which one had the fewest sig figs, and that's how many sig figs are in your answer. Okay, other questions? All right, so you guys are going to do your checklist tomorrow. Getting close. Do you guys have your cheat sheets ready? You should. As you're reviewing, write the stuff down that you want to have for quick reference. Definitely have your notebooks handy. Okay, I'm looking through all of my papers here, and I think we've gone over everything.
Ms. Farkas?
Yeah.
What if Q equals K? Like if they equal each other?
Oh, that's an excellent question. What does that mean, guys?
It's at equilibrium.
That means they're at equilibrium.
Okay.
So if they're equal, then Q really was K. So we can call it K at that point. That's a great question. Okay, I'm going to stop recording. Stop.